So 4/6 is all about simplifying complex fraction. And so right here with this little cat, it says a fraction whose numerator or denominator, or both, numerator and the denominator, contain a fraction is called a complex fraction. Basically, how can we make a fraction uglier? Let's put some fractions in there, all right? So what I want you to remember is method 1. A fraction bar means division. You know how to divide fractions. You flip the second number, right? And then we go from there. So the very first move we're going to make on example 1 is to rewrite this as a division problem with 7y over 10 divided by 1/5 like that. So I just pulled it apart. You guys see that? So the top is 7y over 10, and this fraction bar means divided by 1/5. But do we ever really divide fractions? No, we are going to multiply by the flip of the second guy. So 7y over 10 is going to stay the same, and what's going to happen to 1/5? 5 over 1. You got it, okay? And remember at this point, you do not have to do it my way. If you feel more comfortable reducing right now the way it is, feel free. But what I do is I multiply straight across the top, straight across the bottom, but breaking them down as I go. 7y and 5, none of them can be broken down. So I have a 7 times a y times a 5. Is everybody okay with that? And do you guys agree that 10 can be split up as what? 2 and 5. And then we have 1. So all I'm doing is I'm doing the multiplication straight across the top, straight across the bottom. But I'm breaking them down now so it's easier to see what they're reduced to than making them big numbers first. And so what do you guys notice when I write it that way? They have a common factor of 5. So we'll just cancel out that 5 on top with a 5 on bottom and rewrite it by just multiplying what's still left. What's 7 times y? You got it. And what's 2 times 1? 2. So you guys just did this ugly fraction, and the answer is 7y over 2. Okay? But look how ugly it can get. It says in the next question, again, we got to keep in mind that this is a division bar. But what we want to do is we want to just ignore the bottom for a bit and focus on the top. Let's get the top down to 1 fraction. And then let's ignore the top and focus on the bottom, get it down to 1 fraction. So we can basically make it look like this and do what we just did here. Okay? So I'm going to do kind of my dirty work over here. So this is going to be our numerator. All right? We have 1/2 plus 1/6. Can I add that as is and make it 2/8? No. What do I need in order to add fractions? An LCD. Can anybody look at 2 and 6 and see what number both 2 and 6 go into? 6. Or you can do 12. That's fine. But if you keep it smaller, it makes it easier, right? So again, the multiple method way works. Which is the bigger denominator? 6. Does the smaller denominator go into the bigger denominator? Yes. So we can actually write this as 2 fractions over 6. That first fraction, 1/2, started with a denominator of 2. What did we do to 2 to get to 6? We multiplied by 3. So if we multiplied this by 3, we had to multiply the top by 3. Do you guys agree that 3/6 is 1/2 of a cookie cake? I'll still get my half, right? And then celebrate the small things. What do you notice about this fraction? It stays the same. We didn't do anything to the denominator, so we don't have to do anything to the top. So what is 3 plus 1? 4. And then what do we do to our denominator? It stays the same. If you want to reduce right now, you can, but I don't worry about it until the end. We're going to have to reduce when we multiply anyway. So guess what we can do over here? We can go up here and write this as 4/6. Is that okay? We're going to do the exact same thing, but now with the denominator. Pull that denominator, 3/4 minus 2/3. Can I do 3 minus 2 is 1 and 4 minus 3 is 1, so it's 1 over 1? No. What do I need? A common denominator. Let's do the multiple method way again. Can 3 go into 4? You got it. No. Can 3 go into 8? No. Can 3 go into 12? Yes. You guys see where I'm getting 4, 8, and 12? I'm just adding 4 to itself multiple times, okay? So the denominator is going to be 12. That first denominator was 4. What did we multiply 4 by to get to 12? 3. So what are we going to multiply the top by? 3. So we get 9/12. That second denominator was 3. What did we multiply him by? 4. So what are we going to multiply the top by? You got it. And we'll get 8. So the denominator stays the same, so that's 12. And just do the math with the numerator. What's 9 minus 8? 1. We know that. We don't need to rewrite it as an addition problem or anything. That's just 1/12. So we can go up here and write him as our new denominator. So basically what we did was we took this really complex fraction and changed them into a slightly complex fraction that looked like example 1. All right? What did we do with example 1? We just rewrote it as a division problem. This is just 4/6 divided by 1/12. This is just 4/6 divided by 1/12. But do we ever divide? Nope. So I'm going to rewrite this as 4/6 times 12/1. Is that okay? And then what I'm going to do is I'm going to combine them by multiplying straight across the top, straight across the bottom. But when I do that, I'm going to separate them into their little primes, all right? What is 4 split up as? 2 and 2? What is 12 split up as? 3 and 4, but then what is 4 split up as? 2 and 2. So we'll have a 3, but then we need a 2 and a 2 for 4. I'm doing that without a factor tree, but that doesn't mean you can't go over to your margin and do a factor tree to get your little primes, all right? 6, what is 6 split up as, guys? 2 and 3, right? Because we're doing multiplication. It's so easy to think addition. It is. All right, at that point, guys, notice we can cross out one of these 2's with a 2 down there, and this 3 with that 3. And we're left with 2 times 2, which is 4, times 2, which is 8. What do we have on the bottom? 1, because we had 6 split up as 2 and 3, but those 2's and 3's disappeared. Do we ever write our answer as 8/1? No. What is that the same thing as?
8.
You guys got it. I know you don't think this way, and you're kind of just going through the motions with me. Do you see this ugly fraction right here? That's another way to write 8. That's what we just did. This fraction is the same thing as 8. So if you want to be a jerk on a test, you memorize this, and if there's ever an answer of 8 on the test, you can write that answer down. No, don't do that. I'll probably write it wrong. You know, but you're like, no, do the math. It's 8. All right. So again, I know it seems overwhelming, but if you just focus on one chunk at a time, it doesn't have to be too bad. And like I said,
I would step this, like I did like step 1.
Step 2, and then put them together to step 3 to rewrite them as that. Perfect. Yep. So she's doing step 1, step 2, like that. And then step 3 is to rewrite them like that. And then step 4 is to write it as a division. Absolutely. Yep. All right, guys. We got a couple different methods here now. So,
Snack break between this class.
I know. I feel like I need to start bringing stuff in. And
No, just like a cool out moment.
So method 2, guys, how does method 2 teach us? It says you multiply the numerator and denominator of the complex fraction by the LCD of all the fractions, and this will clear the numerator and denominator of fractions totally, and what's left will be a simple and addition and subtraction problem. This method ends up being easier in the end, but I think it's harder to understand in the beginning. Okay, so let's see what you think. And again, I'm not going to force you to do one way or the other, so you choose which method you like. Okay, so we're going to look at all the fractions, 2, 6, 4, and 3. They're all relatively small, so I'm going to do the multiple method way. Okay, so of these 4 denominators, which one's the biggest? 6. So let's start with 6. Do all 4 fractions go into 6? Well, 2 goes into 6, and 3 goes into 6, but does 4 go into 6? No. So what's the next multiple of 6? 12. Do they all go into 12? Yes. So our LCD is 12.
Okay, so we doing this because of what, right?
It's just a second method.
Okay.
The book always, well, I should say the author, always shows you multiple ways of doing stuff. I personally like the first method. I think it makes sense. Because that's my job as a teacher to show you there's not one right way to do it. There's multiple ways, okay? You pick which way you like though, okay? So what they're going to do is they're going to take each of these fractions and multiply by the LCD. So we're just going to multiply the top by 12 on all of these guys. I know it's kind of small, but I'm just going to multiply all the tops by 12. That's all I'm doing. You're like, well, why am I doing this? Wait and see what happens. What was the first numerator? 1. What's 1 times 12? 12. So that will just be 12 over 2. What was the second numerator? 1. So what's 1 times 12? 12. So that's 12 over 6. Down at the bottom, what was the third numerator? 3. So what's 3 times 12? 36. So that's 36 over 4. And then the fourth numerator, 2 times 12 is 24, and that's over 3. Does anybody see something fishy once we did that?
All them just can just, like...
Divide evenly, right? You're seeing that. We're getting rid of the fractions at that point, right? We're just going to divide evenly. Every single numerator is now divisible by its original denominator, all right? So what's 12 divided by 2? 6. What's 12 divided by 6? 2. We just flip-flopped that, didn't we? What's 36 divided by 4? 9. What's 24 divided by 3? 8. And then this kind of goes back to chapter 1, right? Chapter 1 just says clean up the numerator. So what's 6 plus 2? 8. Clean up the denominator. What's 9 minus 8? 1. What's 8 over 1? 8. So
basically you just find the LCD
of all the denominators and multiply all the numerators by that.
But they only work for a certain type, right?
No, you can do every one like this. You like that way? Let's do it again on this one then. Let's practice it, okay? Yeah. The reason why it works is because how do you build an LCD? The LCD represents every single denominator. So when you build an LCD of 12, 2 can go into it, 3 can go into 4. So we're clearing out those denominators. We're getting rid of them, right? So let's look at this. Okay, he's kind of a trick because what's 1 technically over? 1. Let's just do that just so it stays consistent, you know. All right, so looking at the denominators, we have 4, 5, and 1. So I'm going to do, again, since it's smaller numbers, the multiple method way. So 5 is my biggest denominator. Does 4 go into 5 evenly? Nope. Does 4 go into 10 evenly? Does 4 go into 15 evenly? Does 4 go into 20 evenly? Does everybody see where I get 5, 10, 15, 20? I'm just adding 5 to itself, okay? So what's our LCD? 20. So all we're going to do is go multiply each of our numerators by 20. And we're going to rewrite this fraction. All right? What's 3 times 20? Well, what's 3 times 2? 6, and add a 0. So this is 60 over 4. What's x times 20? 20x, and he's over 5. And then what's 1 times 20? 20 over 1. All right. So this is where maybe you don't know how many times 4 goes into 60, but that's okay, because what's this fraction bar stand for? Division. So if you just need to do a little bit of division down here, that's fine. Okay, we can do a little scratch work. 4 goes into 6 how many times? Once. 6 minus 4 is 2. Bring down your 0. And 4 goes into 20 5 times. All right. So what is 60 divided by 4? It's just 15. Over here, what's 20 divided by 5?
4.
And 4x. X is just going to hang out. And what's 20 divided by 1? Just 20, right? Guess what? We're done. Why can't we go any further on that one? They're not like terms, right? That x was with the 4, so we have 4 x-rays. Take away $20. What do we have? 4 x-rays, and we're in the hole $20, right? So since these are not like terms, we are done. All right, guys. So method 1, method 2, it's totally up to you which one. Either one's great in the teacher's perspective because you're learning LCD and practicing LCDs and adding like stuff. So then all it's going to do is, well, now that you know how to do all the stuff, let's do order of operations. Does order of operations change at all? No. So you know how like this class is kind of overwhelming? At least it kind of rolls into itself. Like what you did in chapter 1, you did in chapter 2, you're just doing in chapter 4 now. PEMDAS is still the same. Parentheses will be first, exponents will be second, multiplication, division are tied, and addition and subtraction are tied, all right? So looking at this one, what are we going to do first?
Correct.
Yep, and what does our parentheses have? A cube. So this is step number 1. So what does 2/3 to the third power mean? Yep, 2/3 times 2/3 times 2/3. So let's just write it that way. 2/3 times 2/3 times 2/3, and who's hanging out at the end? -2. All right. What's nice about, and again, I use nice when you probably want it, but what's nice about fractions when you are cubing them, if they didn't reduce here, like 2 and 3 don't reduce here, they won't reduce when you cube them either, right? The whole top is 2, the whole bottoms are 3s. Nothing's canceling out. And so we just do the math. What is 2 times 2 times 2? 8. 2 times 2 is 4, times 2 is 8. And what is 3 times 3? 9. But what's times another 3? What's 9 times 3? 27. Minus, I'm going to go ahead and write that as 2 over 1. Right? Because we're going to do fractional math, so we need it to be a fraction. All right, can I just do 8 minus 2 is 6, 27 minus 1 is 26? I'm done? No. What do I need? Common denominator. What's really the only real denominator we have? 27. So guess what the common denominator is? 27. Okay. So guess what? This first guy gets to stay the same, and the second guy we're going to multiply by 27, right? 8 over 27 was already over 27. So what's our numerator still? 8. What do we multiply 1 by to get to 27? 27. So what am I going to do? I'm going to multiply the top by 27. If you know it, great. If not, go off and do some scratch work over here. 27 times 2. 7 times 2 is 14. Carrier 1. 2 times 2 is 54. Does that look right? All right. So this is where we would rewrite it as a addition problem. This is 8 plus a negative 54 over 27. 8 plus a negative 54 over 27. Remember, subtraction changes to addition. The second number is opposite. What do you do when you add opposite signs? You really do what? Subtract. And so again, I'm just kind of doing scratch work up here. 54 minus 8. I got to borrow. So that will be 14 minus 8 is 6. 46. Does that look right? Is it going to be a positive 46 or a negative 46? Negative, right? So negative 46 over 27. Sorry, my work is like all over the place. So we said 2/3 to the third power was the first thing we were going to do. 2/3 times 2/3 times 2/3 was 8/27. The subtraction was the other part, so we wrote it as 2 over 1. We looked at 27, we looked at 1, the common denominator was 27. 8 was already over 27, so he got to stay that way. 2 was over 1, so we technically multiplied the bottom by 27, so we had to multiply 2 by 27 to get 54. We can't take 54 away from 8, so we had to rewrite it as an addition problem. And when we did that, it was really subtraction, negative 46. Ask yourself, do they reduce? Well, we know this is a bunch of 3's, and 46 is 2 times 23. It doesn't help us. We don't have to simplify any further. All right, again, I love this because it's great practice. What do we need to do first? The parentheses, and then the second parentheses, and what's the last thing we're going to do? The multiplication at the end. Is that okay if I label it that way? Let's concentrate on the first set of parentheses, the second set of parentheses, and at the end we're going to multiply. All right? So this section's really good because it's just a recap of everything we've done so far. All right? So let's write a giant fraction here, negative something plus something. We need a common denominator for that first set. I feel like I'm drawing like a face there. That's like an alien with his eyes closed. And across is the nose. Do you guys see it?
That's a little one.
This is his little ear. Okay. All right, so the negative, because this first fraction is negative, these are just division bars. And we got to come up with a common denominator between 2 and 5. 10. Multiple rule. 2 doesn't go into 5, so what's the next multiple of 5? 10. And 2 goes into it. So we're going to make each of these over 10. Now he's crying. This alien's crying. Those are tears coming out of his eyes. All right, let's look at that first denominator, 2. What do we multiply 2 by to get to 10? 5. So what do we have to multiply the top by? 5. What's 1 times 5? 5. You got it, guys. Do you guys agree that 5/10 is 1/2? Right? That's the whole idea of it. We want to keep it the same. What do we multiply 5 by to get to 10? 2. So what are we going to multiply the top by? 2. All right, we're almost there. Do you guys agree that they have a common denominator so we can write this as 1 fraction?
Wait, hold on.
Yeah.
How did we get the 10 now?
So what I do to find the LCD, when they're smaller numbers, I
Oh,
look at the,
you find- okay.
yeah, so like I'm just like 5 is my first denominator, but 2 doesn't go into 5. So what's the next multiple of 5? 10. So 5, I'd go like 5, 10, 15, 20 until I got to one that the other denominator went into.
Okay.
What's negative 5 plus 2? Negative 3, right? When you're adding opposites, you're really subtracting. So what's the difference between 5 and 2? 3, and he's negative. So we have negative 3/10 there. So we cleaned him up. All right? Let's go ahead and do this guy. Celebrate the small things. What do you notice about this guy? They have the same denominator. Yes, right? So guess what our denominator will stay as? 8. And we'll just do the math with the top. What's 7 plus 1? 8. That is easy multiplication there, right? Because what's 8 divided by 8? 1. What's anything times 1? That number, right? So negative 3/10 is our answer there. Do you guys see what I did?
Now they just put the other prime there for no reason.
I know. It's like, if it ends up being 1, why don't we just leave that part out? It's one of those things where you just got to catch it, right? We have the same denominator. Yes, that means that denominator can stay in 8, so we'll just do the math at the top. 7 plus 1 is 8. 8 over 8 just reduces to 1. Anything times 1 is just itself. Of course, we got to have these problems where we got to plug things in, okay? We can handle it, though. What operation is this when you have that 2 just shoved right in front? Multiplication, okay? So we're going to take 2, and I'm going to write it over 1. Because you know everything we're doing is with fractions, we might as well just make it a fraction from the beginning, all right? Times x, but what is x? Negative 1/2. Plus y, but what is y? 1/3, but what do we have to do to y? Square it. Look at all that stuff going on. Okay, so we had the 2 there, but I put it over 1 because I know I'm going to do fractional math. Times x, but what was x? Negative 1/2. I put parentheses. From now on, I'm putting parentheses around whatever I plug in because they're either going to be a fraction or a negative or something going on. Plus y, what is y? 1/3, but then what is y happening to y? It's squared, okay? So operations, are we going to do multiplication, addition, or squaring first? Squaring, okay? So this is going to stay 2 over 1 times negative 1/2 plus 1/3 times 1/3. Is that okay? And so now we've kind of made it 2 multiplication problems. So at this point, guys, I'm going to do this multiplication problem, leave the addition sign, and then this multiplication problem, all right? So what's a positive times a negative? Negative, and so this is just 2 times 1 on top and 1 times 2 on the bottom. Remember, I just multiplied straight across the top. 2 times 1, 1 times 2, and we're going to, you see something happening there, right? Plus, what's this just going to be? 1 times 1 and 3 times 3. So when I do multiplication, I just shove it into one fraction first before I worry about simplifying. All right, help me cancel these things out. What happens here? They all cancel out. So is that just 0? No. Remember when we canceled out, and it's kind of my fault as a teacher, when we cancel it out, it's 2 over 2, which is 1. So we could be putting 1s all over the place, but it just kind of clutters it up. But you need it there when you need it, okay? So that's a negative 1. And then what's 1 times 1? 1. And what's 3 times 3? 9, okay? So we're almost there, and you're like, crap, there's one more thing we're going to have to do, okay? So we have negative 1 plus 1/9. But what do we have to do in order to add these two things? We need to make him a fraction with a denominator of 9. So what is he technically over right now? 1. So our denominator is going to be 9. Celebrate the small things. Can we just jump to the back real quick because we're excited because he's already over 9, right? Let's do the easy stuff for sure. And that's what I want you to do. If you get stuck, you're like, I don't know what to do to him to get to him, but I know 1/9 stays 1/9, do that. Anything you can do correctly, you're going to get points for. What do we multiply this denominator by to get to 9? 9. So what are we going to multiply him by? 9. So we end up with -9/9 plus 1/9. What's our final answer there? -8/9. Look at that. That's stuff that you guys struggled with in chapter 2 that you're getting now. Whenever you add opposite signs, you're really subtracting. What's the difference between 9 and 1? 8. Who's the bigger one? The negative? You guys rock that.